The slope field for a certain differential equation is shown to the right. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 0? Well, y of 0 equals 0 is going to be the point 0, 0. So let's label it x and y. Let's go to 0, 0, and our slope is 0. So what we need to do is I need to basically look at all of these and see which of these is going to be matching up if I plug in 0, 0. So I could probably eliminate one or two or maybe even three of them if I plug in 0, 0. If I plug in 0, 0 here, I do get 0 over negative 4, so you will check out so far, so A is an option. If I plug in 0 for tangent, tangent of 0 is 0, and 2 plus x is 2, so you will check out. If I were to plug in 0 here, I would get e to the 2, so c is not an option because I will not get 0. And if I plug in 0 here, I get 0 over 2, which is 0, so you seem to check out. Now this is what I need to do. I need to kind of look at the picture that I have and try to figure out what kind of pattern that I have going on. Okay, it looks to me that if I were to put a point at negative 2, I have myself what appears to be a vertical asymptote at negative 2. Okay, which means you would do that for me, you would do that for me, you would do that for me. It also appears that as if I were to pick a point like here, if I were to pick a point and notice the behaviors of something, it looks like this guy kind of slopes down and shoots back up like this. Okay, shoots back up like that, which indicates here some type of horizontal or slant rather asymptote. Now only one of these is going to give us a slant asymptote, and a slant asymptote exists when the degree in the numerator is one more than the degree in the denominator, and that happens to be d. Okay, you would level out at 0. You would have a horizontal asymptote at 0 because the degree in the denominator is higher than the numerator, and that's not the behavior that we're seeing here. We're showing behavior where it seems to, our graph seems to be increasing along 0, not leveling out. And if you're wondering, well, why not tangent? Why not tangent? Because this doesn't seem to be exploding again. Okay, tangent would do that. Tangent would have like another explosion and hit zeros again after a specific pi value, and that's not happening here. So B is not going to be it.